Alright class, welcome to another lesson. Today's learning goals are I can identify the base and exponent in a power expression, and I can convert a number between expanded form, exponential form, and numeric form. And we'll talk about what all three of those mean, but we need to first identify the base and exponent in a power expression. So a power expression is anything that has an exponent. So for example, 3 to the fourth is a power expression. Okay, so let's go ahead and get started. 5 to the fourth, this is a power expression because it has an exponent. The base is the big number. It's the number that we're going to multiply over and over again. So that in this case would be the 5. Okay, so the base is the number that you're going to multiply over and over again. The exponent, okay, is the number that you are going to, number times you're going to multiply that number by. So right here, this is the exponent. So this means it's going to be 5 times 5 times 5 times 5. So 4 5s being multiplied together, and because 5 is the base, 4 is the exponent. And like we just said, expanded form is what this is in multiplication. So 5 to the fourth in multiplication means 5 times 5 times 5 times 5. Okay, so this is expanded form. Notice how it's really long. Okay, and it is not simplified. If we want to simplify, okay, this is going to be the numeric form. The numeric form is going to be a single number. So that means 5 times 5 times 5 times 5, which is it's 125 times 5, which means it's going to be 625. Okay, because 25 times 25 is 625. Let's try another one. Ooh, here. Okay, here we have negative 3 to the fourth. Okay, notice how this negative is right beside the 3. And this 4 is right next to the 3. Okay, this one, okay, the base is not negative 3. In this case, it's 3 because this 4 right here, this exponent, okay, the exponent is 4 right here. This 4 only applies to the thing that it's right next to, and it only applies to this 3 right here. Okay, so what is this expression in expanded form? This is negative, parentheses, 3 times 3 times 3 times 3. Okay, that's what this is, because this 4 does not apply to this negative right here because it is not right next to it. Okay, so 3 times 3 times 3 times 3, put a negative in front of it, just like how this negative is right in front of the 3. Okay, again, the exponent only applies to the thing that is right next to it. So what is this one simplified? So 3 times 3 is 9, 3 times 3 is 9, so we got 9 times 9, which is 81. So our final answer is going to be, in numeric form, this is called numeric form again, is negative 81. This one looks very similar. Okay, the only difference is that the negative 3 is in parentheses, and this one it is not. Here, this exponent, okay, the 4, applies to the thing that's right next to it, which is this parentheses, okay, which means that it applies to everything inside that parentheses. So this one, okay, has a base of negative 3. Okay, so this base is negative 3. Was this an expanded form? Since the 4 applies to the negative 3, all of it, okay, that is going to be negative 3 times negative 3 times negative 3 times negative 3. Okay, and if we simplify that, here, negative 3 times negative 3 is 9, negative 3 times negative 3 is 9, so 9 times 9 is 81. This one is positive 81. Okay, again, it's very important to distinguish the difference between parentheses negative 3 to the fourth and negative 3 to the fourth. Okay, different. They both, even though they're both 81, one's negative, one's positive, because the exponent applies to all of this in this case, the exponent only applies to the 3 in this case. So here we have 8 times 8 times 8 times 8 times 8 times 8 times 8. So we have 1, 2, 3, 4, 5, 6, 7 eighths. So to write this in exponential notation, we're going to use a base of 8 because that's the number we're multiplying, and the number of times we're multiplying that together is 7 times. That's a 7. Let's try that again so it doesn't look like a 2. 7. Okay, 8 to the 7th power. Here we have negative 3 times 3 times 3 times 3 times 3 times 3. Okay. Here, this one is as if there was, so this is going to be a negative answer, right? Okay. So we're going to have the negative on the outside. So this is 1, 2, 3, 4, 5, 6. So we're going to have 3 to the 6th power. Okay. Notice how this is going to give us the exact same result as we talked about earlier, which was negative 3 times 3 times 3 times 3 times 3 times 3. It's all going to be the same because it's still the same number of 3's being multiplied with a negative in front of it. That's why it's negative 3 to the 6th. Okay. What is, this is millions, billions, what is 10 trillion, okay, in exponential notation with base 10? Okay. So how many times do I have to multiply 10 in order to get 10 trillion? We can figure this out by taking a look at how many zeros there are. So there's 3, 6, 9, 12. 12 plus 1 is 13. So there's 13 zeros here, which means we're going to have an exponent of 13. So it's going to be 10 to the 13th power. Okay. So this again is the numeric form of 10 to the 13th power. The exponent form of this would be 10 times 10 times 10 times 10 times 10 and so on 13 times. So we are asked what is 5.2 or 5 and 2 tenths times 10 to the 5th power. So what this is, 5 to the 10th power is 10 to the 5th power, excuse me, is 100,000, right? Because we have 5 zeros, so it's 5.2 times 100,000. Which means that because there are 5 zeros, just like this exponent tells us there, it's going to be, that means we're going to move the decimal over 5 times. So 1 time, 2 times, 3 times, 4 times, 5 times. When we do that, we go 5, and then we move the decimal over once, so we have 52. Then another times, that's twice, 3 times, 4 times, 5 times. In numeric form, 5.2 times 10 to the 5th is 520,000.
All gone. Finished. All done.